Okay, everyone, welcome back to the second part of the minerals notes. So, the first part of the minerals notes, we talked about the physical characteristics of a mineral: hardness, luster, streak, the chemical composition, um, the cleavage or fracture, meaning the way it breaks. So today we're going to take a look at some of the secondary features, the more chemical things, things that are not quite as physically testable. So second part of minerals, here we go. All right, so the chemical composition, all right, what a mineral is made of. So where we take a look at this, all right, the average chemical composition, right, of Earth's crust, hydrosphere, and troposphere. But for our purposes, we're just worried about the crust today, right? And this is going to be another chart in the reference tables. This is page 1. So if you take a look on your reference tables, on the front cover, on the bottom, here is that chart, the average chemical composition of the crust, hydrosphere, and troposphere. And again, we are only concerned in this case today, right now at least, with the crust. All right, so the crust is going to be the rocks. Okay, so the crust is made up of rocks. So when we take a look at this, we have percent by mass and percent by volume. So percent by mass just means the amount of mass each of these elements make up, all right? Percent by volume, volume meaning the size. So if we take a look at the mass, all right, percent by mass, your two largest are going to be oxygen and silicon, making up 46.1%, right, and 28.2% of the percent by mass, followed by a bunch of other things. So when we take a look at our minerals, I'm sorry, it jumped out. There we go. When we take a look at this, all right, here is the crust percent by mass, right? And our two most abundant, meaning most of, is the oxygen and silicon. All right, so silicon and oxygen are the two most abundant elements by mass, right, in Earth's crust, right? Abundant meaning the most. Okay, so there is the most silicon and oxygen in Earth's crust. Again, take a look back, go back, right? 46% oxygen and 28% silicon. Okay, so that are the two most abundant elements. Okay, next we have the structure of the mineral, meaning how that mineral is built. So this is internal. We can't see this, right? But we have ways to test it. So minerals are made up by atoms, meaning those smaller elements, and they're arranged in a very specific pattern, right? This is what makes them a mineral. Okay, if you remember earlier in the previous video, some glasses are not considered minerals because glasses don't have a specific pattern inside. Minerals do, okay? And this pattern is going to determine all of the physical and chemical properties of that mineral, okay? So, for example, all right, we have what is known as a silicon-oxygen tetrahedron, okay? Well, if you remember to math, right, your prefix tetra, right, tetra meaning four. So what is the name of a shape that has four sides? Okay, most of you are thinking, well, I know a triangle has three sides. What is the shape that has four? Now remember, we want a three-dimensional shape, so we're not looking at triangles. Square has four sides, but it doesn't have four faces. So a shape is going to be a pyramid. Okay, so pyramid has three sides around, and then we always forget about the base. So all four of those faces, those sides, are going to be equal in size. So when we think of that silicon-oxygen tetrahedron, it is made up of silicon and oxygen, right? There's going to be one atom of silicon, and it's going to be located in the center of this shape. Now, where do the four oxygen atoms go? Well, they are going to be around the outside on the corners. So here is that pyramid shape. Okay, and we always forget about the base. So we have one side, two sides, three sides that's facing us right here, and then the base. That is our fourth side, making the silicon oxygen tetrahedron. So I wanted you in this picture to label it. This is one of the most common shapes that we will take a look at and be asked about. So where is the silicon going to go? We know that there's one silicon, so which of these has only one of that shape? So right in the center, that's your silicon. So label that Si. All right, remember Si is short for silicon. Bottom of page 16 of your reference tables has that. Now, we know that there are four oxygens in this tetrahedron. So where do they go? they're going to go around the outside to surround it, making that pyramid shape. Silicon, oxygen, tetrahedron. Now, why is that important? Because it gives minerals their certain properties. Okay, well, another bit of about minerals is some miscellaneous information. Certain minerals are known as carbonates, meaning that they are going to react or bubble with hydrochloric acid. I mentioned the two earlier on the reference tables, all right? And if you remember, those two minerals are going to be calcite and dolomite. So if I jump back to the reference tables and we go to page 16, right, here's page 16, sorry. All right, and we look at page 16. All right, we want the distinguishing characteristics, and if we scroll down, right, we have here bubbles with acid, right, calcite and dolomite. And this here, this CO3, that is what is known as the carbonate, right? Those are carbonates, so they will both bubble with acid. I know it's a little tough to see, but this is the acid drop right here, right? And we can see those bubbles in there. Okay, it's actually really cool. When we get the opportunity in the lab to see it, you will. Right? Next, right, we have diamond and graphite. So they're both made of the same material. Yes, the inside of your pencil, graphite, and the hardest and most valuable substance on Earth, diamonds, are made of the same material. So let's figure out what graphite is made of. Reference tables, let's find graphite. Graphite is up here, right? Here is graphite. Graphite is a metallic mineral that is composed of the letter C. So what is the letter C? Scroll down to the bottom. Right? C is carbon. So both graphite and diamonds are made up of carbon. Right? And what mineral is this? This is graphite. This is what graphite looks like when it's not in your pencil. What is the difference? The difference is how they are arranged internally, the internal arrangement of atoms. Diamonds are connected by what we call a lattice network, so you have a much stronger connection, whereas graphite is set up into layers and actually flakes off. So if you take a look at your pencil, right, this is essentially the shaft of your pencil going straight up, and these are the layers of graphite. And when you drag your pencil, kind of like I'm doing here on the left across the paper, this is one layer, this is another layer, this is another layer, and they flake off and give you that grayish, blackish line when you're writing with the pencil. All right, so what is the hardness of a diamond? Well, we know from the Mohs scale on the previous video, diamond has a hardness of 10, whereas graphite has a hardness of, we look at graphite, graphite has a hardness of 1 to 2, which is very, very, very soft, right? Same composition, different internal structure, different internal arrangement of atoms, completely different mineral, both made up of carbon. Okay, so a couple of questions. What is the difference between cleavage or fracture? And this is just a review. So if you remember, cleavage, right, and fracture are both ways that a mineral breaks. So cleavage is going to be the even break along smooth parallel sides, whereas fracture is that uneven break. Okay, fractures will have wavy sides, uneven, none of the pieces will look the same. Cleavage, you can have, let's say, halite or salt, which every single piece, no matter how big or small, is going to have those 90-degree shapes. All right, so almost every piece is going to look like a cube. Next, what are the two ways that we classify a mineral's luster? So we get that answer from the reference tables. So we look here, luster, we have metallic, right? And the other one is non-metallic on the bottom. Either means it can be either metallic or non-metallic. So we have metallic and non-metallic are two different types of lusters. Number 3, how can you tell the difference between calcite and halite? Again, reference tables. So you jump to your reference tables. Here is halite, right? And here is calcite. So we can go across, right? Halite is softer than calcite is. Right? Calcite has a hardness of 3, halite has a hardness of 2.5. They both have cleavage. That doesn't help. They're both colorless to white. Colorless are variable, so they're pretty much clearer color, right? Halite, though, has cubic cleavage, salty taste. Calcite will bubble with acid, right? So, simplest way, though, if you're trying to tell the difference between the two, and this is just one way, right? halite, right? HCl is your hydrochloric acid. Calcite will react with it. Halite will not. Halite has cubic cleavage. Okay, again, right from the reference tables, just comparing two different things. Okay, number 4, right? If a mineral can be scratched by a fingernail, can be scratched by a penny, not by an iron nail, what must its hardness be? Now, you don't have to remember these things. Just look in your notes and it will always be given to you. The hardness of a penny was 2.5. The hardness of, I'm sorry, the hardness of a penny was 3.5. The hardness of a penny, I, sorry, fingernail was 2.5. Penny was 3.5, right? And the iron nail was 4.5. Okay, so the hardness must be, if it can't be scratched by this, but can be scratched by this, the hardness is going to be about 4, which is between these numbers. Okay, and lastly, number 5, what type of mineral will bubble or react when touched with acid, right? And I wanted you to give me an example. So we call these carbonates. So a carbonate mineral has to be made up of the mineral calcite. So calcium carbonate, right? Those are your minerals. Okay, again, answers right from the reference tables. So that takes us to the end of part B, much shorter. I just didn't want to include it into one big long video. Again, if you have any questions, please feel to reach out to me on Teams or Remind if you have any questions.